Hi students, in this video I'll be going through the 2017 O-Level Mathematics Paper 1 question 15. Right, so as you can see, this is a question related to the properties of circles. Right, so let's read the question. So in the diagram, A, B, C, and D are points on a circle with the center O. Okay, AB equals to 8.1, BC equals to 13.8, and angle BDA is equals to x degrees. Okay, so what they want us to do is to find the value of x. Okay, show your working and give reasons. Right, so let's take a look at examine the question diagram more closely. Right, so you see that the angle x exists over here. Okay, it's angle BDA lah. Okay, so in the triangle BDA, you can see that besides angle x, we only have one other side. Okay, we do not know any angles inside that triangle. Okay, so it's practically impossible to proceed any further to find x. So when you do a math question, sometimes one question must ask yourself whether if you remain in that particular, in this case, you remain in this particular triangle, okay, will you be able to proceed any further? Okay, so in this case, we can see that we can't proceed any further. Then the next question that you can ask yourself is, will I be able to find an angle that is equal to x degrees, also equal to x degrees in this diagram? Okay, then you should realize after looking around, okay, that it's quite obvious that we will be able to find x at angle BCA, okay, because of the property of angles in the same side. Okay, so once again, if you can from point B, okay, I go down to the circumference of the circle at point D, and then for another point A, I go to the same point D. Okay, so I form an angle X, right? Okay, so if I move back, okay, back to point A and B, and then from point A and B, I'm able to extend to another point C, okay? Okay, and then from B, meet at the same point C. Okay, then these 2 points will be angles in the same segment. Okay, because they lie on the same side of the circle. Okay, if you draw a chord A and B, right, they will both lie in the major segment. Okay, so basically AB will divide the circle into 2 parts. Over here you have the minor segment. Okay, then the other large part will be the major segment, which is this part. And both the angles BDA and BCA, they both lie in the same segment. All right. Okay, so let's go ahead and write this point. Okay, so over here this will be x degrees also. So you can write our working over here. Angle ACB is equals to angle ADB. Okay, so another thing to know about angle in the same segment is that these two should be the same. Okay, the only changing thing will be the point at the center. All right. So this will be angles in the same segment. Okay, so this will be equals to x degrees. All right. Okay, so once we have identified that x also resides in this triangle, okay, this triangle looks more promising because at least we know 2 lengths. Okay, so we know that if you know 2 lengths in a triangle, and if the triangle happens to be a right angle triangle, then we will be able to apply trigo ratio, right? Okay, so now the next thing to look at, is there a right angle in this triangle? Okay, so one thing to pay attention whenever you see a center over here, okay, so there's a center at point O, right? And there's a line passing through the center. Okay, then that line is the diameter of the circle. Okay, so the line terminates at 2 points on the circumference of the circle, so AC will be the diameter of the circle. Okay, and if we have diameter of circle, then we should be looking out for the property right angle in a semicircle, because the diameter will cut the circle into 2 semicircles. Right, so in this case, we can identify the angle ABC is going to be 90 degrees. It's a right angle in a semicircle. The semicircle will be A, B, and then go down to C. All right. Okay, so let's write down that point. So once we have identified the right angle at ABC, we will be able to apply trigo ratio already. Okay, so angle ABC is equals to 90 degrees. So this is a right angle in a semicircle. Okay, semicircle. Okay. Okay, so we'll be able to conclude that hence triangle ABC is a right angled triangle. Okay, since it's a right angled triangle, then we can apply trigo ratio. So the angle that we are interested in is over here, x. Okay, so this side will be the opposite side, and then this 13.8 will be the adjacent side. Okay, the side AC, the diameter, is opposite the 90 degrees, so that will be the hypotenuse. Okay, so since we have O and A, then we will be able to use a tangent. Okay, so therefore, tangent x degrees is equals to AB opposite over BC adjacent. Okay, so let's sub in the values. We have 8.1 over 13.8. Okay, then we will do a tangent inverse. Okay, then we will be able to get 30.4 degrees. Okay, so this means that x will be 13.4. Right, so this is a 4-mark question, but as you can see, it's not too difficult. So once again, I repeat, the original x in this triangle, you can't do much because there's only one side given. So you try to find x somewhere else in the diagram, and it should be quite obvious in this case that you can apply angles in the same segment, okay, to transfer x over to triangle ABC. Okay, then ABC, AC passes through the center, so it's a diameter, then you will be able to identify the right angle in a semicircle, which makes the triangle right angled triangle. Then you can apply trigo ratio. Alright.